Hello everybody. Today's learning objective is about surface chemistry. Surface chemistry is the branch of chemistry which deals with the phenomenon that occurs on the surface or interfaces. For example, you can take catalysis, corrosion, crystallization. All these come under the surface phenomena. Molecules or the liquids or the solid present on the surface behave differently from that present in the interior. A molecule in the interior of the liquid is surrounded by similar molecules on all sides, and hence the intermolecular forces of attractions are exactly equal in all directions. On the other hand, the molecule at the surface of the liquid is surrounded by a large number of molecules in the liquid phase and by fewer molecules in the vapor phase. So the molecules will experience some net inward force of attraction. So similar inward forces of attraction exist on the surface of the solid. Okay. So this unbalanced inward force of the attraction exists on the molecules at surface of the liquid and a solid, and this causes them to attract and retain the molecules of gas or dissolved substances coming in contact with their surface. So the phenomenon of attracting and retaining the molecules of a surface of a substance on the surface of a liquid or solid is called adsorption. I'm repeating. Adsorption. See, what is adsorption is the phenomenon of attracting, retaining the molecules, attracting, retaining the molecules of substance on surface of a liquid or a solid is known as adsorption. Due to unbalanced attraction forces, accumulation of molecules, species at surface rather than in bulk of the solid or a liquid is termed as the adsorption. So it is a surface phenomenon. There is unbalanced inward force of attraction that is existing on the molecule. It is existing on the molecule at the surface of the liquid and solid, and this causes them to attract and retain the molecules of the gas or a dissolved substance coming in contact with the surface. So the phenomenon of attracting and retaining the molecules of substance on surface of liquid or a solid is known as adsorption. Okay, so due to the unbalanced attraction forces, there is accumulation of molecular species at the surface rather than in the bulk of the solid or liquid. It's called as the adsorption. So the molecular species accumulates at the surface is termed as adsorbate, and the material on the surface of which adsorption takes place is called adsorbent. So O2, H2, Cl2, Nb3 gases are adsorbed on surface of the charcoal. Silica gel gets adsorb water molecules from the air. See, it doesn't go into the it doesn't go in. It's on the surface. So the silica gels adsorb the water molecules from air. Next, charcoal, silica gel, metals such as nickel, copper, silver, platinum, and colloids are some of the adsorbents. So wherever the molecule accumulates at the surface is termed as adsorbate, and the material on the surface which adsorption takes place is called adsorbent. Okay, now let us see the important characteristics of adsorption. Now, important characteristics of adsorption is it is specific and selective in nature. Adsorption is a spontaneous process. Therefore, change in free energy is that is delta G is negative. So delta G is equal to delta H minus T delta S. It's called T delta S. For negative value, For negative value of G in a system where the randomness is decreases, delta H should be negative. Hence, the adsorption is always exothermic. So this adsorption process is a specific one and it is selective in nature and it is a spontaneous process. It is a spontaneous process. The change in free energy is negative. So delta G is nothing but delta G is equal to H minus delta G is equal to H minus T delta S. For the negative value of the G in a system where the randomness decreases, delta H must be negative. Hence, adsorption is always exothermic. Adsorption of the hydrogen over platinum is called occlusion. Now we'll see what is desorption. So, adsorption, a surface phenomenon. Yeah. Coming to the adsorption, is a surface phenomenon and it is therefore a fairly rapid process. The substrate is a solid substance on which adsorption takes place is called adsorbent, while adsorbed material, gas or a liquid is called adsorbate. And good adsorbents are the solids in a finely divided state, while adsorbate may be while adsorbate may be gases or liquids. For example, in the decolorization of sugar solution by activated charcoal, charcoal is the adsorbent while the coloring impurities in the sugar solution are adsorbates. Similarly, in the refining vegetable oils, the fuller earth is used. Fuller earth is a adsorbent while dissolving color impurities are adsorbents. So the term adsorption should be distinguished from absorption. The term adsorption refers to attraction and retention of molecules of a substance only on the surface of the solid, while the term absorption refers to passing of the substance through the surface into the bulk of the solid. So two examples of the absorption are given below for clarification. Ink is absorbed by the chalk. It is absorption. Ink is absorbed by the chalk. That is absorption. And few water droplets added to the lump of sugar. Water is soaked for the entire mass. So that is absorption. Now, absorption involves diffusion into the interior of the mass. Absorption involves diffusion into the interior of the mass. It is slow process. Absorption may be followed by dissolution of the absorbed substance in the absorbent. The first stage, the material appears on the surface of the absorbent and then passes into the bulk of the adsorbent. So that happens when hydrogen is taken up by metallic palladium. Two processes, when considered together, are known as sorption and the reverse sorption. That is, release of adsorbed or absorbed substance into the surrounding medium is termed desorption. Sorption of gases by metals is known as occlusion. Sorption of gases by metals. Sorption of gases by metals is occlusion. Now we'll see desorption. It is a process of removing an adsorbed substance from a surface on which it is adsorbed. Is known as desorption. The process of removing an adsorbed substance from a surface on which it is adsorbed is known as sorption. Now, the distinction between the desorption and absorption. So, adsorption involves unequal distribution of molecular substances in bulk and at the surface, whereas absorption involves distribution of the molecular species through the bulk. It is the surface phenomenon, adsorption, whereas absorption, it occurs throughout the body of the material. Absorption occurs throughout the body of the material. It is rapid in the beginning, adsorption. It occurs at the uniform rate. Absorption occurs at the uniform rate. Adsorption is rapid in the beginning, but absorption is always uniform in its rate. Now we'll see what is sorption. Sorption is a process in which both adsorption and absorption takes place simultaneously. The sorption, it is simply used. It is a process both adsorption and absorption takes place, comes under sorption. Now positive and negative adsorption. When concentration of the adsorbate is more on surface of the adsorbent than in the bulk, it is positive sorption. It is called as the positive sorption. When concentration of adsorbate, when the concentration of adsorbate is more on the surface of the adsorbent than in the bulk, it is positive adsorption. On the other hand, if concentration of the adsorbate is less relative to its concentration in the bulk, it is called negative adsorption. It is called as the negative adsorption. Next. On the other hand, the concentration of the adsorbate is less relative to the concentration in the bulk. It is called as a negative adsorption. Example, when a dilute solution of KCl is shaken with blood charcoal, it shows negative adsorption. I hope you have understood clearly about the negative adsorption and positive adsorption. So when the concentration of adsorbate is more on surface, the adsorbent, than in the bulk, that is positive. And if the concentration of the adsorbate is less to its concentration in the bulk, is called negative adsorption. Okay, when dilute solution of KCl is taken, I've told you, with the charcoal, it gets the negative sorption because the concentration of adsorbate is getting lesser. Now, we'll see the distinction between physiosorption and chemisorption. It arises when adsorbate molecules accumulate on the surface of the adsorbent on account of weak van der Waals forces. How the physiosorption occurs? It occurs when adsorbate molecules accumulate on surface of the adsorbent on account of weak van der Waals forces. Chemisorption, it arises when adsorbate molecules accumulate on surface of adsorbent on account of chemical bonds. Physiosorption occurs at low temperature. Chemisorption occurs at high temperature. Heat of adsorption is low and it is in the range of 20 to 40 kilojoules per mole. Heat of adsorption is generally low for physiosorption. And here the heat of adsorption is high and it is in the range of 80 to 240 kilojoules per mole. Physiosorption is a reversible process, whereas chemisorption is the irreversible process. Physiosorption is multi-layered adsorption, and thus adsorption layer is several molecules thick. Monolayer, the chemisorption is only monolayered. Thus, adsorption layer is only unimolecular in the thickness. Now, what are the factors that are affecting the adsorption? As I've told you, physical adsorption is otherwise called as van der Waals adsorption. Physiosorption or the van der Waals adsorption. When a gas molecule is held adsorbed on surface of the solid by weaker van der Waals forces, the phenomenon is known as physical adsorption, since no chemical bond is set between the adsorbate and the adsorbent. Next, Chemisorption. When a gas molecule is held on the surface of a liquid by forces similar to that of a chemical bond, the adsorption is known as chemical adsorption. This chemical adsorption leads to the formation of so-called surface compound. Now let us see the factors affecting the adsorption. We have seen different adsorptions and the types of adsorptions. Now, what are the factors that are affecting adsorption by gas of the gases by solids? It can be nature of the adsorbent, factors affecting adsorption of gases by the solids are nature and surface area of the nature of the adsorbent, surface area of the adsorbent. And the third one is nature of the gas that is being adsorbed. And the fourth one is temperature. And the fifth one is pressure. See, let us have a detailed look onto this one. The factors affecting extent of adsorption, extent of adsorption, nature of the adsorbent here, and surface area of the adsorbent. Some gases may be adsorbed to different extents on different adsorbent. And greater the surface area, greater is the adsorption. Obviously, you can understand as the surface increases, the surface area increases, adsorption also increases. Now, the extent of adsorption of gases by solids depends upon the exposed surface area of the adsorbent under the given conditions of temperature and pressure. The greater the surface area of adsorbent, greater is the gas adsorbed. Thus, substances like charcoal and silica gel are excellent adsorbents because they have highly porous structures and hence large surface area. Next, the substances here. This can be easily explained by the finely divided substances absorb power than the compact form of the same substance. The absorbing power of these substances can be further increased by activating them in various ways. So now let us have the second one, the nature of the adsorbent and the adsorbate. Here, nature of the adsorbate and adsorbent. The amount of gas adsorbed depends upon the both nature of the adsorbate and the adsorbent. The gas that is being greater is the critical temperature of the gas, greater are the van der Waals forces of attraction, and thus greater is the adsorption. See, greater is the critical temperature of the gas, greater will be the van der Waals forces of attraction, and more is the adsorption. See, here you can observe for sulfur dioxide, adsorption is more, even for ammonia, and then for HCl. Because what you can observe is the critical temperature is more. Now, coming to the temperature, adsorption is exothermic process involving the equilibrium. Gas plus solid, gas adsorbed on solid plus heat. We have to apply Le Chatelier principle. Increase of temperature decreases the adsorption and vice versa. Now, the pressure. Adsorption increases with pressure at constant temperature. The effect is large if the temperature is kept constant at low pressure. Now, activation of the solid adsorbent is also a factor. Activation means increasing the adsorbing power of the solid substance, of the solid adsorbent. This can be done by subdividing the solid adsorbent or by removing the gases already that is absorbed by passing superheated steam. Now, we'll see. Yeah, this one. Adsorption isotherms. It is a plot of the mass of gas adsorbed per gram of the adsorbent, X by m versus equilibrium pressure at constant temperature. Now, we'll see before telling the adsorption terms, adsorption isotherms. Before telling that one, what is the effect of temperature? What is the effect of temperature? Like any other equilibrium, Adsorption is the process. Adsorption is the process involving true equilibrium. Further adsorption takes place with the liberation of heat. And what is the effect of pressure? At constant temperature, adsorption of gases increase with increase of pressure. At low temperature, the adsorption of gases increases very rapidly, very rapidly as the pressure is increased. The increase in adsorption with increase in pressure is not proportionate at high temperature. Next, adsorption isotherms. And physical adsorption and chemical adsorption, they can be influenced. They have high specificity. They are influenced by nature of the gas, effect of temperature. Now, van der Waal adsorption has following characters. The physical adsorption, it has no specificity and nature of the gas. Higher the critical temperature of the gas, more readily it is absorbed. Effect of temperature. Since van der Waal forces are stronger near the critical temperature or below the critical temperature, physical adsorption are strong at low temperature. Increase of pressure enhances condensation of the gas. Physical adsorption increases with pressure. Physical adsorption is a reversible process in terms of pressure and temperature. In terms of pressure and temperature, the physical adsorption is reversible. As the surface area, greater the surface area, greater is the physical adsorption. And greater is the surface area, greater even the chemisorption. And coming to the temperature, increase of pressure increases chemisorption. And due to this, like chemical changes, chemisorption increases with increase in temperature. This is due to highly activation energy. So the gases may be adsorbed physically at low temperature and chemical at high temperature. Okay, now we'll see the adsorption isotherms. What is an adsorption isotherm? As mentioned earlier, quantity of the gas adsorbed, you previously mentioned, adsorption isotherms we'll see. The quantity of a gas adsorbed by given amount of adsorb depends upon the temperature. It depends upon the temperature and pressure. At constant temperature, adsorption of a gas on solid surface increases with increase in pressure of the gas. So the relationship, here I'm repeating, adsorption isotherm, the relationship between amount adsorbed by an adsorbent and the pressure of the gas at constant temperature is called adsorption isotherm. Is called adsorption isotherm. Freundlich adsorption isotherm. Freundlich gave empirical relationship between quantity of gas adsorbed by a given amount of solid adsorbent surface and pressure of the gas at particular temperature. Freundlich adsorption isotherm. Freundlich gave an empirical relationship between quantity of gas adsorbed by given amount of solid adsorbent surface and pressure of the gas at particular temperature. X by m is equal to Kp to the power n. X is the weight of the gas adsorbed. X is the Freundlich isotherm, empirical relationship between quantity of the gas adsorbed, the quantity of the gas absorbed by unit mass of the solid adsorbent and pressure at particular temperature. Here it's given by equation X by m is equal to Kp to the power n. X is the weight of the gas adsorbed by m grams of adsorbent at pressure. X by m represents amount of gas adsorbed per gram of the adsorbent. K and N are the constants at particular temperature. Okay. So the above Freundlich relationship is found to be valid by plotting amount of gas adsorbed against the pressure, where curves of the type shown. So Frewenish isotherm can be tested by taking the graph. X is the mass of the gas adsorbed on the mass m of the adsorbent at pressure P, K, N are constants. These depend on the nature of the adsorbent and the gas at particular temperature. Here we get this one with the graph. So by plotting a graph, how you have to do the validity testing the Frewenish isotherm, taking logarithms on both sides. We take logarithms on both sides. Here we are testing with the graph. At low pressure, n is equal to 1. Here a graph is drawn, x mass of the gas adsorbed on mass of the adsorbent at P. K and N are the constants which depend on the nature of the adsorbent and the gas at particular temperature. So x by m on y-axis, P on the x-axis. And at different temperatures, you get the isotherm. This is one isotherm. At one particular temperature, different plottings. And this one at 244 Kelvin, this is the different plotting. So this is one isotherm, this is another isotherm, and this is another isotherm for adsorption. This is given by Frewenish isotherm. So at low pressure, n is equal to 1. At low pressure, n is equal to 1. So x by m is equal to Kp. X by m is equal to Kp. Low pressure n is equal to 1. X by m is equal to Kp. At high pressure n is greater than 1. X by m is equal to K. It is independent of P. Now we are taking logarithms on both sides. Log x by m is equal to log K plus 1 by n log P. Now let us plot log x by m versus log P and on the x-axis and y-axis. So you get a straight line. We get a straight line with slope 1 by n, intercept on y-axis. This is equal to log k. The factor 1 by n can be values between 0 and 1. Now, the Frewenish adsorption equation for solutions. We get x by m is equal to k into c to the power 1 by n. X, as I've told you, x, it is the amount mass of the gas adsorbed on mass m of the adsorbent at pressure P. So C is the equilibrium concentration. Now taking logarithms on both equations, we have log x by m is equal to log k plus 1 by n log C. This is for solutions. Okay, this is for solutions you get. How this is helpful for us? So thus the Frewenish isotherm can be tested by the graph taking log x by m against log p. The plot must be a straight line. So in actual practice, reasonably straight line plot is often obtained, particularly if the results at low and high pressures are neglected. The values of n is generally less than 1. So the isotherm is used here. Adsorption of the solutes from the solutions, and it has been found to work better with type of adsorption than gases. The pressure in the expression is replaced by equilibrium concentration for the solutions. Yeah, P is replaced by C for solutions. Okay, so this Frewenish isotherm can be expressed even for the solutions and for the gases. So C, it is being replaced by C. You get a plot, and by taking the plot slope intersect, we get the isotherm, and we can find out the relationship, the quantity of the gas adsorbed on unit mass of the solid. Now, here Frewenish is able to explain for the physical adsorption, but what about the chemical adsorption? Longmire deduced a theoretical relationship which has been found to be more agreement with many experimental facts over the wide range of pressure than the Frewenish isotherm. So actually Frewenish adsorption isotherm is only a special case of the Longmire isotherm for intermedial pressure. The main points of the Longmire theory of adsorption are summarized below, which can be explained. Summarized below, but the postulates are not given. I'm going to explain you the postulates also. Adsorption takes place on adsorption for the Longmire. The postulates are adsorption takes place on the surface of the solid and fill the whole surface is completely covered with unimolecular layer of adsorbed gas. Adsorption consists of two opposing processes: condensation of the gas molecules on the solid substance, evaporation of the gas molecules from the surface back into the solid. Now let us see, basing on these postulations, the rate of the condensation depends upon the uncovered surface of the adsorbent available. The rate of condensation depends upon the pressure of the gas, since according to kinetic theory of gases, number of molecules striking per unit area is proportional to the pressure. Now let us go on for the derivation of the Longmire. According to Longmire, the degree of adsorption is just directly proportional to the fraction of the surface area occupied. Fraction of the surface area occupied. X by m is proportional to theta. X by m is equal to k theta. But theta is equal to kp by 1 plus kp. Kp is equal to, further derivation you get theta is equal to kp by 1 plus kp. X by m is equal to theta. So therefore theta is nothing but kp by 1 plus kp. X by m is equal to kp by 1 plus kp. So this is the final on derivation, complete derivation you get Longmire adsorption. The derivation is not given, but I'm just explaining you the Longmire adsorption system and the validity through graph. So x by m is equal to kp by 1 plus kp. So if p by x by m is plotted, p by x by m is plotted, it is plotted against p. So p by m is plotted against p. You get this type of graph, theta. Theta is the answer. Now at high pressure, 1 plus kp is equal to kp. X by m is equal to x by 1 plus kp is equal to kp. Therefore, x by m is equal to k prime p by kp. Now at low pressure, 1 plus kp is equal to 1. This is equal to 1. Therefore, x by m is equal to k prime p. And at moderate pressure, x by m is equal to k p to the power 1 by n. 1 by n is value, it's from 0 to 1. Now, what are adsorption? So this is the way Longmire has given for the chemisorption. Now, what are the adsorption isotherms? The plots of x by m versus temperature at constant pressure. And for physical and chemical adsorption, they're shown below. Here these are the adsorption isobars at constant pressure. If you see, this is the adsorption isobar. Yeah, this is one more isobar. Chemisorption, this is one isobar, and physisorption, this is isobar, and chemisorption, you get this way. And what is adsorption isotear? These are the plot of temperature versus pressure for given amount of adsorption. Yeah, adsorption isotear. It's a plot of temperature versus pressure for adsorption. Okay. Now, what are the applications of adsorption? I've told you in the starting of the class, purification of the vegetable oils we use. What we use is fuller earth is used. Okay. So for production of high vacuum adsorption process, gas masks containing activated charcoal for breathing in the coal mines, so that the dust gets adsorbed, and they adsorb the poisonous gas also. Silica, aluminum gel are used as adsorbents for controlling humidity. Now, removal of coloring matter from solutions. It is used in heterogeneous catalysis, in separation of inert gases. Okay. The adsorption indicators also, adsorption process is used. And in chromatographic analysis also, we use the phenomenon of adsorption. And in the qualitative analysis example, Lake test for the aluminum, we use adsorption phenomenon. Okay, I hope you have understood clearly about the adsorption. There is a brief outline which I gave you for the adsorption. So what is adsorption? What is adsorbate? And what is adsorbent? The types of adsorption, surface chemistry, positive adsorption, negative adsorption, sorption, all these were explained for you. And the important characteristics of the adsorption and examples also explain. Now, I'm going to explain you about the catalysis. A brief introduction of the catalysis I'll give you. So, catalysis is a chemical substance which can change the rate of reaction without being used up in the reaction. It increases the rate of reaction, decreases the activation energy. That process is called catalysis. Now, Haber process, we use iron and molybdenum is a promoter. Ostwald process, manufacture of nitric acid. Platinized asbestos are used as a catalyst. Contact process for H2SO4, we use platinized asbestos. Lead chamber process for sulfuric acid, we use nitric oxide. Decon's process, we use cuprous chloride. So catalyst can be positive, which increases the rate of the reaction. And sometimes it can even decrease the rate of the reaction, it can be negative. So if the right one is not taken, then we get the negative catalysis. Now, what are the types of catalysis? Homogeneous catalysis. Here, the physical state of the reactants and the physical state of the products all are same. That is homogeneous catalysis. Now, what is heterogeneous catalysis? So in heterogeneous catalysis, the catalyst is present in different phases than that of reactant. See here, one is in solid, the other one is the gaseous state. What is catalysis? Autocatalysis. When one product of the reactant acts as the catalyst, that process is called autocatalysis. And the catalyst remain unchanged in the mass and chemical composition. It doesn't go any chemical reaction. And they are the reversible reactions. Once if it it enhances any reaction, again that will be back. So it is a reversible reaction. Now, what are the promoters and poisons? Promoters are the chemical substances. See, for the Haber process, I told you iron is the catalyst and molybdenum is the promoter. Promoter will promote the catalyst, activity of the catalyst. Well, poisons are the ones which decrease the activity of the catalyst. You're having heterogeneous catalysis here. This is the catalyst, intermediate formation, and the catalyst. See, catalyst and the reactants. Catalyst is attached to the reactants. Here, diffusion takes place. The mechanism, diffusion of reactants to the surface of catalyst, and adsorption of the reactant molecules on surface of catalyst, and occurrence of chemical reaction on the catalyst surface through the formation of an intermediate. Now, desorption of the reaction products from the catalyst surface will take place here. After completion of the reaction, again, desorption takes place from the product molecules. Again, it diffuses from the reactant products away from the catalyst surface. Now, what are the important features of solid catalyst? One is the activity and the second one is the selectivity. Again, you have the shape selectivity. Activity is the activity of catalyst depends on strength of the chemisorption to a large extent. So the sorption should be reasonably strong, but not that strong that the movement is restricted. Next, six selectivity. So features of a solid catalyst, activity should be more. So it should be strong, but not too strong. Selectivity. To the selectivity, selectivity of catalyst is ability to direct. It is the ability of the direct. The selectivity of catalyst is the ability to direct a reaction to yield particular product. Example starting with here, hydrogen, CO uses different catalysts, we get different products. A CO and hydrogen gas in presence of nickel, methane, and water is formed. Carbon monoxide and H2 gas in presence of copper, zinc, chromic oxide, methanol is formed. Carbon monoxide and hydrogen gas, formaldehyde. What you have to observe is the reactants are the same, and depending on the catalyst, the products are formed. So that is selectivity. Now, shape selective. The catalyst reaction that depends upon the pore structure of the catalyst and size of the reactant and product molecules is called shape catalysis. Cracking isomerization of the hydrocarbons in presence of zeolites is an example of shape catalysis. Okay. The important zeolite catalyst is used in petroleum industry in ZSMS. It converts alcohol directly into gasoline. So, what is enzyme catalysis? Enzyme catalysis are the complex nitrogenous organic compounds which are produced by living plants. The enzyme is a biocatalyst. They enhance so many biochemical reactions. Enzyme and substrate will form enzyme substrate. And again, enzyme is liberated and the product is here. Lock-in key mechanism. Yeah, exactly, it should fit into the substrate. Yeah, after that, the reaction proceeds. And again, the product is formed, enzyme comes out. You can take some of the examples. Sucrose in presence of invertase, it gets hydrolyzed to water, glucose and fructose. Glucose in presence of zymase, it forms ethanol. Starch in presence of dietase, it forms maltose, and maltase converts to glucose. So urea gets hydrolyzed in presence of ureas to ammonia and carbon dioxide. Now, catalyst for the enzyme what are the characteristics? It should be highly efficient. Yeah, this in stomach also you can see pepsin is converted into pepsinogen that converts into peptides. Proteins are converted into peptides in the intestine. So lactobacillus is used to convert milk into curd. All these are the biocatalysts. Now, what are the characteristics of an enzyme catalysis? It should be highly efficient, highly specific in nature, optimum temperature. It should have optimum pH. So enzyme can transform 1 million molecules of reactant per minute. That is the efficiency. It should be specific. As I've told you, each reactant will give different products. So each catalyst, each enzyme will give different products. And the temperature should be optimum for high yield. The body temperature should be suited for the enzyme catalyst. Optimum pH. The rate of the enzyme catalyzed reaction is maximum at optimum pH 5 to 7. So activators like ions, Na plus, Ca plus 2, Mn plus 2 helps in activation of enzymes which cannot act on their own strength. Coenzymes are the substances having nature similar to that of enzymes and presence increases the enzyme activity. So what is the effect of inhibitors which slow down the enzyme activity? Is the, as I've told you, poisons and promoters, similar ways the inhibitors and enzymes. So which decrease the enzyme activity? These are the inhibitors. I hope everybody have understood today's class, which is about the surface chemistry, the types and the factors affecting adsorption isotherms and catalysis, enzyme catalysis. Thank you all for listening to my class.